slow down this one and see because there's a menu on the bottom. It doesn't really show what it's supposed to. Okay, here we go. So let me go to share our class PowerPoint. Here we go. Okay. All right. So you can see PowerPoint. Okay. I had opened some other windows with different programs like SPSS. So I want to make sure you see what I see. Okay. So confidence interval, and we decided to cover today instead continue what we have done with the t-test. And a confidence interval is a really not really just directly related to t-test, but confidence interval. Any statistical analysis you do, they provide the confidence interval. If the confidence interval includes some of the hypothetical value of your population, sometimes based on the confidence interval, you can make interpretation and inferential statistics. Okay, so I will go over that, and then once we practice SPSS with the independent sample t-test, that is what we covered this week. When we do that, you will see it automatically provide confidence interval. So I want you guys to understand how you can use that number and sometimes how you can interpret that as more generalized ideas about what you found out of the data and the sample. Okay. So we call that as interval estimator, all right? So for example, we try to guess sample mean, all right? Then it's a point estimator. So like this little point right here in the middle or somewhere, any point of the value in your sample. In that case, usually it provides you, well, that is more, based on what we discussed in hypothesis testing, it can provide the probability. So based on the probability of that point estimator, we can say the value that is more likely to occur, right? It is a value is less likely to occur. So that was hypothesis testing we covered so far. But we can kind of stretch not from the point estimator as more of a range and as an interval. Okay, so by having interval, the good thing is instead of like a 1 point estimator, it's a correct or incorrect. Rather than that, we have a broader range of interval, actually saying that the real value, the population value is more likely to belong to within this range. So it is more likely to provide some of those flexibility based on your sample statistics. So that's interval estimator rather than using one single point, but range of the point. Okay. So we call, in other words, we can call as a confidence interval. So when we have a confidence interval, from here to here, mostly the interpretation wise, we are, conventional way, most general way we can say is that we are 80% confident that our population value will belong to this range, or 90%, or 95%, or sometimes 99% for sure. The real population value will, from somewhere from lower bound here to upper bound here. So that is a confidence interval. How you can calculate it? It's quite simple, all right, in terms of how you can stretch from the point estimator. Usually point estimator is a sample mean or sample proportion or sample probability, whatever that estimator you use, you kind of pull that from your sample. It's a point of value. But in order to make the confidence range in interval, and you stretch from the main point and the center point, whatever the value you wanted to look into, From there, how far, from the negative side and the positive side, from the center point, how far it goes out to the both side to cover some values in a range of values with a certain confidence interval. So how you can find it, let's say if your point estimator is a sample mean, that's what you want to find. But again, that sample statistics can be varied based on your research question. So if we try to find the sample mean, what is the sample mean? From the value is really estimating good population mean. And then, just let's see the range with some confidence level. So if our question is about the mean, then from the sample mean, you go to positive to negative side, how much? So again, depending on the statistic value of z or t, okay? So that's what we know so far. And so z value when we have a normal distribution and large enough sample size. And as what we discussed on Tuesday class, right? When we have a sample size, especially sample size less than 30, cases, right? It's not of arbitrary number, right? But let's cut in 30 as sample size in order to meet central limit theorem. So if it is more than 30 sample size, then it converted t value converted to z value. So that's the decision we made, right? So when we cannot meet general assumptions for the z statistics. So especially we don't know everything about the population value, especially the variability value for the population. That's very common that we don't know, right? So, and thus we should calculate it from sample. Then it automatically gets changed from the z statistics to t statistics, right? So depending on the sample size, whether you have all population values or you need to estimate something from sample, then you're gonna move to the t-test. So anyway, t and z statistic value for what you are doing, and then multiply by standard error. So that is a confidence interval so from the center point, the positive side, how far you want to go, t or z statistic value multiplied by standard error. Okay, and the negative side, and a z or t value, statistic value multiplied by standard error. Okay, so that provides you, for example, if we use the z statistic value of 1.96, that is the specific z value for 5%, right? So the both side was 0.025%. So it is really 95% confidence interval. Okay, we are confident that the sample, our estimated sample range will cover population value in that range about 95%. Okay. And then let's think about, you can be flexible, moving, around with the confidence interval, right? And statistics, we don't really say 80%. 80% is a quite ambiguous cutting point, right? 20 is not that big, but not that small either, right? So again, when we talk about confidence interval, we use a conventional values of alpha value. When we set 5% or 1%, confidence interval goes the same way. Sometimes you set the confidence interval manually. Usually, by default, all statistical software, they provide the confidence interval at the 95% of confidence level. So having like a two-tail test, 2.5% here, the positive side, 2.5% for the negative side. But if you wanted to increase the confidence level, it's a good thing. If you provide some statistical value, if you are like 90 90% confident. That's more confidence, right? But there's some off. Let's say if you want to be 100% confident, okay? In order to have just 100% confident in terms of age, what is the age group that had the highest level of social media usage for the political information? We want to estimate that from the national survey. Then if you want to be 100% confident, then you can cover from age 0 to, as I know, the oldest person in United States by the record, he lived on, up to 113. Okay, maybe there are more people, but let's say you want to cover all the age from 0 to 113. You will be 100% confident, but doesn't mean anything, right? It just include all age group. It doesn't really say any meaningful statistical value there. So having large sample size, 95% or 99% confidence, you can just narrow that specific age group with much more precision and also accuracy and effectiveness. So that's the purpose of confidence interval. So do not try to really say, I want to be 100% confident. In statistics, we don't have such a thing. All right. In order to be 100% confident, that means you have a body in your sample, about your population, and it's just about everything. All right. So the conventional confidence interval value is 95% or 99%. So in order to increase confidence interval from 95% to 99%, it's just simple. Again, you replace Z value, Z statistics or T statistics value from where it is the value for 95%, and then replace with the statistic value at 99% borderline. Okay, so simply replace it, and then the confidence interval gets a little larger and wider. Okay, so that's how you adjust your confidence level. Okay, so again, like alpha value, the most common confidence interval is 95% or 99%. Okay. So the important matter is, so whether you do regression tests or, some two group comparison, multiple group comparison, and you will see they will provide confidence interval. Okay, so I want you guys understand and know how to use those values and numbers in writing in the report, and how you can just take advantage of that value. Okay, so confidence interval is just basically the mean is if we do numerous tests, experiments. So out of 100 experiment, okay, if you have a 95% confidence interval, you can say that 95% of the time, this range is more likely to cover the actual population value. Okay, or you can say in the long run, okay, 95% of the time, we are correct that actual population value will belong from this lower bound to this upper bound. That's how you can interpret the confidence interval. Okay, so depending on your research question, you estimate your population value to 50, for example. Okay, so whether your confidence interval eventually cover, that value in it, then maybe it is, you're not. I'm sorry. I should take it back. So let's go slow here. So when your confidence interval include any of your null value you want to test for hypothesis. Okay, if nothing is happening, everything is the same, there's no relationship. If you fix any of those null values, if the null values are included in confidence interval, you cannot reject null hypothesis, right? But if you find your confidence interval to the all positive side or negative side, not including whatever null value, whether it's a 0 or a 50, whatever it is, then it really turned out as statistically significant. So you will see if the confidence interval include your null value, then the actual statistical analysis will provide you high probability, so you cannot reject it. And your confidence interval actually do not include your null value for null hypothesis. The actual statistical analysis will prove that it is statistically significant, because we can reject the null with a 95% or 99% confidence. We know that null value is not part of this confidence range, so we can reject it. Instead, we can confirm what we wanted to confirm as alternative hypothesis. Okay, so I will show you how we can interpret with the very first statistical analysis, so we're gonna do today. Okay, so regarding just questions you want to practice, I think in order to grasp up what we talked about this week, just go back to the end of the chapter book chapter, and I'll just try to practice a question number 12 and 20. And if there's any question, let me know. All right, you're visiting my office hour or just during the class session, you can always ask me a question. Okay, so now let's move on to SPSS practice. Okay, last 2 weeks we played with the ANS data set. So why don't you, Dylan, why don't you open and pull out GSS 2024 data set? So out of that, I want just practice couple of tests using one sample t-test. Okay. So Dylan, when your data is open, let me know so we
Got
can.
it open.
Okay, perfect. All right, great. So just let's come back to what we are doing right now, okay? So just to be honest with you, what we're gonna do today is really the basic form of statistics based on the z-test and t-test, right? But especially when we are dealing with a sample, it's gonna be made, mostly it's a t-test anyway. So still, it's not like the real world statistical analysis yet. We are not comparing anything like such as like a Republican versus or Democrat, or the minority versus or the white, or not like that yet. Okay, but that will be more of the statistical analysis we're gonna cover actually next week. Okay, next week. But still, up to this point, we are dealing with a very much simple form of the t-test. So what we covered on Tuesday class, we wanted to see whether this matters or not. So when we have some medicine, whether my sample mean is different from the general population value. So in other words, this medicine work or not. Okay, so also maybe when we can talk about, there's a lot of political and social changes moving along with the COVID, new administration, and polar opposite, the administration and back and forth. So I wanted to see people are still like leaning to certain party or they're neutral. So how our population in 2024, we are dealing with the 2024 data set, right? It might be still like a, you know compared to last 10 years or 20 years, how we have been, or it might be different. So the question is how your sample mean is different from the population mean. Okay, so that is the purpose of the simple, independent one sample test. Okay, I'm sorry. So one sample t-test. So we have one sample. How that is different from the population. So we are still doing pretty much a very simple thing. So let's say that is the hypothesis we are dealing with. So we can do that. Let's practice where we can go. All right. So I actually found two variables we can measure it. It quite interests. I don't know. Maybe Dylan, you think really we are that polarized? We are really that much, like different from previous years or something like that. One of the variable actually we visited before. Okay, where is your leaning between left and right? So it is sort of a broader question. GSS data set asked, are you left or right? So we can embrace a lot of information there. Partisanship, some way of ideology, right? So I want to see whether really American, people, American voters are really like different from the center. So it's not only like, surrounding those center, most of them were really the opposite direction or, leaning to anywhere. So we can test that. And also another one was more of those Gen Z question, right? So in AI era, with a lot of those economic, based on economic index, it doesn't look great, right? So when we ask the people, especially in 2024, what they think about their expectation getting good job. All right. So whether that expectation is more positive or negative, so that is different from what you think as the center point. So let's measure that. Okay. Why don't you start with the left and right question here? Okay. So the question number 299. Let's see. And GSS data, they actually did a pretty good job to cleaning up. They already code all those missing value as a missing. But as you see, they have left as a 0, right is 10. Okay, doesn't mean they have only 1 or 10 valued, only 2 values, not. If we go back and double click it, and you can go to data view, and then you can see it's from 0 to 10 and some of with some of missing value, and they express that where they're leaning to. Okay, so having 0 to 0 to 10, I think the mean value for the population for null value, if people are not really leaning to right or left. So null value maybe should be 5 out of 10, right? So let's use a 5 as the value of the estimated population value, but you can put in based on your theory, you can put different numbers, okay? But let's go. So in order to run any kind of mean comparison, you can actually go to compare mean and proportion, and then you can go to one sample t-test. when we have the sample, get one sample, and we have some estimated best guess the value about the population, then you can move forward with the one sample t-test. Okay, so go to analyze, compare means and proportion, and then what we covered from Tuesday, it is about one sample t-test. Okay, so next week we can actually move on to independent sample test, and then a paired sample test, and then we move to ANOVA test when you compare multiple groups, more than two groups. So just we will cover that, but now at least for one sample t-test, what we covered in terms of the theory. So go to there. And then you can see, okay, there's a new pop-up window, okay? And the variable, whatever the variable you use, you should move from the list of variable to test variable. So it was a left, right one. As I mentioned, that one of the trick is type first three letter or three numbers, whatever, how it is listed as a name of the variable, and it automatically goes to that variable or closer to that variable. But anyway, GSS data set, they listed variables based on the alphabetical order. So it might be easier for you to just keep going down to, in that order. But anyway, this is the variable I wanted to measure. And we already know it's from 0 to 10. So assuming that Americans are totally neutral, okay, that's null value, but many theories really argue that, well, we are divided. We are leaning to this direction or the other direction. So what we are testing is a null value 0. I'm sorry. In some cases, it should be 0, but in this range of the measures and in our values of from 0 to 10, and I would like say 5, then no, we are totally fine. We are totally neutral. Okay, so that's a null value. May we wanted to falsify to confirm that we are not totally neutral. Okay, so just to put that number there. Okay, and then in the option actually show that, okay, do you want to have the confidence interval at 95%, or you can change it to 99% as well. Okay, so it is up to you, but 95% is the most conventional value, so we're gonna go from there. So let's simply run, and what they're gonna provide you here. Okay, so as I mentioned that, I think at the second week, right? Let's make it a little bigger here. I should do this way and that way rather than I don't know why it seems like it doesn't work. Okay, so as you see, whenever you run the test, okay, SPSS have a new pop-up window as output window. So that is the window they show the result. Okay, so for your future analysis, if you save your data right here, if you save your data, it's not gonna save output window. So when you want to save something we done, maybe in the class or during your project, you always should save the output window separately, independently from the data. Okay, so you need to save in two different things. It doesn't really automatically save at the same time. Okay, so one sample t-test. So out of our sample, let's see, it is mostly first table provide the descriptive values, and usually second or third table they provide its a statistic value. Okay, so as you see here, sample size 2651. Independent sample t-test, do you remember from Tuesday class, the degrees of freedom? Okay, so we fix one variability value there. So how many values are free? It's n-1. Can you see n-1 is a degrees of freedom here, right? 2,651 minus 1 is 2,650, right? So I didn't lie, right? And so let's look at the t-value here. T value is 6.56. So sometimes you can automatically think about highest value T and Z value can go is like a 3 and 4. Beyond that, it's a very strong statistical value against null value. So sometimes by looking at this value, you can automatically see with the large sample size. But they provide a probability here, the corresponding probability out of the sample. They actually provide ones tailed test, in other words, one-sided p-value and two-sided hypothesis test. Both are almost zero. So almost zero probability for null hypothesis. Okay. So we are not gonna have really the value 5 in our population value. So look at here. The confidence interval difference, but you can actually write actual confidence interval. So how you can say the interval difference is from the mean value, which is 5.33. Okay, so actually you can just go to 20, subtract 0.23 from 5.33. Okay, so it's gonna be a value 5.1, right? So lower like a bound to go down is still above 5, right? And then upper bound is like a 0.43 larger than mean value, so which is 3.76. Okay, so the actual confidence interval with 95% confidence, it actually goes from 5.1 to 5.76. So that's a confidence interval with a 95% confident that the population value will be from 5.1 to 5.76. That's how you can really argue. And since there's no zero value there, right, you can argue that we are in 95% time, we are not likely to include the value of 5 or like a mean difference is 0 from the 5. So it is statistically significant. That's how you can argue. That's the conclusion you can make. All right. So as I mentioned that earlier, when you report the T value and a rounded bracket 2650 close equal 6.57. That's the value you're going to report for the T value. And that one sample T statistics prove that it is statistically significant. American voters are not really neutral, not at the center, but they're leaning to more likely to be conservative or more Republican side slightly. That's how you can argue that. You got that? That's interpretation. All right. Now let's do actually a little bit of review and another t-test. Once we get that, and rest of the time you can just play with what you wanted to do. Let's talk about. I found that the one couple of the variable above here about the job expectations. Okay. So Dylan, and do you really agree with all those policymakers and media, news coverage that our job market is really, really bad. There's no job you can find. Do you agree with that, or what do you
So
think?
I graduated from undergrad a year ago,
Mhm.
and I couldn't find a job. I moved. I was kind of like freaking out because I moved all over the like I stayed with friends all over the country, and I couldn't. I was like I guess unhireable or something. I tried so many different avenues. Like I put out probably 500-600 applications, and in the course of just under a year, because I kind of gave up because I was like I'm just going to go back to school.
Okay.
Um, so yeah, I got like some replies back, but I was pretty shocked at how like difficult it was to
Mhm.
find employment after university. Like it really, really bad.
Okay.
So
So thank you
that's
for
anecdotal. That's totally anecdotal. So you know,
no, totally. And that is the nationwide stories about young college educate and they cannot find job. But it's the same story whether you go to college or not. It's like a nationwide trend with high inflations, more of a job cuts, federal level, state and local levels. And with the AI and they kind of just new tech companies, they stop hiring any additional new entry jobs. So it is true. That's what we feel. And actually, telling you as a person you experienced. But you know what? I just want to give you some good, um, positive and actually to factor information. And when the economic index doesn't look good, okay, the best thing that's the move you can do is actually you come back to and investigate in your on yourself and continue your education. So when the job market gets more opportunities, now you can jump in, especially this bad job market. Situation, and now most of entry job they do not want to hire anyone because of the cost. If you are in education, you are getting the master's degree, your job opportunity will be multiplied. Okay, because now people are hiring more of those higher end job, not entry job, right? So having master's degree, it's gonna be a way you can kind of jump over all those like a gray area. What are we gonna do and how are we gonna do? So I'm very happy that you made a good decision. Okay, that's actually what I did too. Around the time I was out of college, it was national economic like a monetary crisis. So there's a hire, but they got a call back, and no, we actually canceled the job position. That was nationwide and internationwide, and I
that
was just
actually happened to me. I got hired from, and then there was it like the contracts got cut from the government, and so I was like super excited to get a job, and then it just
yeah,
disappeared, and I'm like so
yes. We really never know, what really happened, and that really became more of the common practice these days when like earlier like your parent generation when they got a job offer that is permanent, but now you got a job offer, it can be like you can get a phone call next day, all right? So that's another lesson. If you are in a certain position and you apply for now, your generation, we don't consider it a lifetime career. Your career changed throughout the life, right? With all the changes coming to your life. So when you actually transitioning from one place to another place, when you got hire confirmation or email, whatever you have, until you start to work to that office and you get a form, it's legally, they cannot reverse that. You should be very careful about what you're doing in the current job, for example. Okay, so it's some of the things. our even faculty member made as a mistake, right? They thought, okay, bye. I hate this, this universe. I'm going somewhere, and then like less than a month, and he can leave. All right, so things like it's a very much changing job market that it make people very down, especially those people who are usually laid off. 70-80% of people actually get rehired less than 3 to 4 month period. But now, according to national statistics, that like a prolonged unemployment, it gets longer and more. So I think we are heading to some sort of economic crisis. All right. So, but anyway, I think you are.
That's what everyone has been saying, is that we're facing a pretty serious recession. I'm no economist, but that's fun.
Yeah, but that's also something you can expect, that when the economy is something, they want to stay in certain way. So when it hit the bottom, it just jump up right over. That's the tendency of economic trend. So that means sometime soon it might gonna just bounce up, right? So we don't need to be always down about this expectation, but there are still some of area, like for example, how this AI, for example, they are all crazy about AI, and I don't see AI will be just like how much we scared of, how much we excited about the computer when we had a first time computer in our human, life. So it will help, but it's not gonna replace a human being. Never. You see the limitations already, right? So that is something yeah, we really need to talk about. And again, I'm not only teaching statistics, but once you are in the graduate program and you are taking the courses, and the graduate faculty members, we are walking with you to get to where you are going. All right. So again, Dylan, I'm sure you have also other faculty member, but I'm here too to talk about your concern, and especially when you apply for the job. And I can give you my best advice, and also I can write the reference letter. Okay, so just be you. You'll be good. You'll be good, and you're right position now and right place. Okay, so thank you for sharing your personal story. So that really reflect in how the current economic conversation goes on nationwide. So I think maybe it's a good variable to maybe measure. So it's between late 2024 and then early 2025. But that's the data set they completed here, collect and completed. And also this is maybe just very timely, the measures of American people's view. So they say, well, do you think you can find equally good job, or maybe not? So let's say the rest of them may somehow do not. They call it as a missing, and then they said one is very easy. Yes, it's very easy to find good job, and two somewhat easy, and three not easy. So again, in this kind of a circumstance, when we run mean tests, intuitively, the higher mean value is intuitively good, better, and more, right? And usually the negative value is, well, more negative, loss, and not related or something like that. But here, we wanted to do, once you have the mean value and outcome, we make sure it's good intuitive values can make interpretation. So it's a 1, 2, 3 coding system. But once we get a higher value out of that later for the mean value from the sample, it's more positive, and lower value is more negative, but that is more intuitive, right, for the interpretation. So let's recode that. One, yes, very easy. Positive one is number 3, and then as the value 3, and 2 stays at 2, and not easy. Oh my God, it's really, really hard and really bad and really negative. Let's code it, 3 to 1. So once we ran mean value, more than 2, people are more positive, and smaller than 2, people are more negative, right? So it makes more sense. Otherwise, if we use the variable the way it is, you have a hard time. It's less than 2, that means it's more positive. It's confusing, right? So let's record it. So let's see. Go to transform. We already practiced this one before. So recode into different variable. So here, the variable, job bind, that is the name of a variable. So click here anywhere. Let's go job bind. I just type first 3 letter. So it moves on here. And then we want to make the new variable. So same variable. Okay. Bind, but reverse code. And then maybe you can see reverse coding. Again, label is for any of information once you're back and you want to know what you did, right? So if you do click change, it will change out with the new variable name. So you haven't done your job yet. So let's go to old and new value. Then there's another new pop-up window. So how you want to recode it? Okay, so I want to say number 1 will be number 3. Very much, yes, it's easy to find a job. Then 2, yes, somewhat, yeah, so. And then number 2 stay as that. And then number 3, oh, it's hard. Okay, so number 1, so it's more pessimistic, all right? So once we have all the mean value out of that, it will be easier to interpret it. And since all other variable, you can copy as all the missing value and then put as a missing, or you can simply say all other values as a system missing. Okay, doesn't matter. So you can, they automatically exclude negative, 99, negative 98, or something missing, inapplicable, and anything exclude from your analysis. Okay, so continue. Then come back to main, pop-up window, say okay. Then there's nothing changing here. We didn't do any analysis yet, but only the thing is we can see here at the end of the data set, you can see reverse coding of a job finding variable. So you can put it here, number 1 as very hard. So something like that, right? Okay. Not hard. So we know, so basically now we do analysis, we know what we did, but maybe next time you're back, we wanted to make sure, especially for your project, you recode and clean some of your variable. You wanted to know what you did, right? And let's say somewhat number 3 is very easy. Okay, so that's clean. And now if we go back to data view, you see those are already excluded as missing rather than having all this and excluded. So either way is fun. You can just copy all the values, new value, and then you can come back and actually you can put, the missing value as it is. You can do that as well. So let's actually test this variable and how American voters and past, so between like about the end of summer in 2024 and January and February of 2025, how American voters feel about their job lookout. Okay. So let's go to. So I'm sorry. So in terms of hypothesis, okay, in terms of all national observation and statistics, in terms of what Dylan you see as your personal experience, we really see it's more negative, right? It's not very, full, good picture. So we want to prove, okay, it's not like it's just normal. It's not positive, but I think it's more negative. So that's your alternative hypothesis you wanted to confirm by theory and by experience. But what you wanted to disprove is that no, people are not really positive or negative either, or it's positive, right? That's what you wanted to falsify and nullify. Okay, so that's like from 1, 2, 3 coding, although it's ordinal, but actually we can use as interval. And then so if nothing is really different, maybe we want to use still like a value 2 as a null value, but we want to see people are more or less positive. Okay, so again, let's go to analyze, compare means and proportions, and then we go to the second on the drop down menu, one sample t-test. That's where we go. So let's reset. Okay, usually when we do multiple tests with the same statistics, they save the previous analysis. So you can simply reset or remove it. Let's say job fund. That is what I wanted to measure, but I expect that our null value is 2. Not 1, not 3, but 2. Exactly, people are not more or less just see negative or positive about their job market. All right. So now let's just simply click OK and see what they provide us. Okay. Here we go. When we have this the sample, actually we found that people are still more positive. Okay, so it's a null hypothesis when say people are not less or more positive and negative, but if they are exactly the center, that's very unlikely. It's a probability is almost 0. Instead, when we look at the mean value, it's more than, I understand, Dylan. You say 0.12, is that statistically meaningful? Just think about the populations, the sample size. Anything more than 200, that's a significant, robust value. So even sometimes a 0.15 or something like that, that can be statistically meaningful. Okay. So anyway, when we considering this sample size, our t-value got 5.609, and then our mean value, and then actually the mean differences doesn't include the 0 value. It's not 2. The center, actually from the sample, the lower bound from the mean is still positive and upper bound is much more positive. So we can say the actual 95% exact, the range, not by difference, is 2.12 plus 0.8. So it's gonna be 2.2. That's a lower bound, how people goes down to. And then upper bound will be 2 mean plus the upper bound will be 2.12 plus 0.16 is gonna be 2.28, right? So we are 95% confident that Americans still see they can find their job somewhat okay, and yes, they will find that will be easy. They are more leaning to the positive side of it. Okay, so how much by 0.2 and 0.28 toward the positive side. Okay, so it turned out unlike what we expected, but maybe somehow also it is the data set it was collected during the peak of the campaign, right? The both side of the politician, presidential candidate, and also actually the economic index toward the end of the Biden administration, it was pretty good. Although Republican Party continuously sell out the negative information, how bad it is, but job placement, unemployment rates are down and inflation was going down. So when we look at some of the actual the economic index, it was pretty good. So maybe around that 5 or 6 month of a time period, the people really gradually see, yeah, it will be better. Yeah. But what you see, maybe what we see over like just a year, continuously in the bigger picture, it's really getting bad. It's getting worse. But maybe this data set really see that time period, it was not that bad. Okay, that's how we can confirm and make interpretation. Dylan, go ahead.
Or also, like, it would be interesting to look at like data that comes out of like that specifically talks about specific fields, like careers, and like say that like overall the trend is positive. But if you look at like people who work for like government employees, or like that would be an interesting like avenue of research as well, if this was your research topic. I don't know. That's what I'm thinking. I don't know.
Great insight, Dylan. Exactly. So if that is actually another way, maybe we can dig. Maybe let's go to maybe their occupation, right? It's a politics or business. It might the same variable, maybe select, you know how to select variable, right? Going here, data and select cases, right? So if you do select only government sector, maybe it really turned out as negative, right? Maybe you select some of those specific age group, like your young Gen Z group, may turn out it's negative, more negative compared to the general population. It's fascinating, great insight, Dylan. That's how actually you do statistics. Beautiful. So as you see, okay, we hypothesized. Our hypothesis is economic projection is not very good. So American voters, we see it's negative about the finding decent job. That's my alternative hypothesis. We tested null hypothesis for that, but actually turned out the opposite. Actually, majority of them are more positive. Why is that? So when we sort out different, business sector, professional sector, and different age, it might gonna have the opposite direction, or maybe we cannot reject a null, or sometimes it's more negative. Yes, that's how you do the analysis. Okay, great. Great. So actually, this is what I wanted to cover, and just to practice, at least to show how to run one sample t-test. So Dylan, do you have any question about, so far what we have done about one sample t-test?
I get off the top of my head, no. But usually, when I have like after a while, when I have a question, it like comes to me, and I'm like, and then. But I've done a pretty good job of trying to answer those outside of class when they come to me. Like when I'm, for instance, when I was doing my research, I was like, "Ooh, I have some questions," and then I just kind of like figured it out, I guess. So no, I mean, I for sure will have more questions, especially about like SPSS.
Yes.
I actually
that's the way Concur SPSS is. Like when we have a new software, I feel like it's a very strange alien thing. But once you start using it, become yours, right? So exactly same way as the PSS, so you just play around and just run things, and it will be eventually will be your software. But still, it's a new, still like you kind of just say what to do, and but just jump in it and do whatever you want, and then it will eventually you can list as PSS as one of the skill you have in your resume for sure. That's also I will write when you asking me to write recommendation letter from what I taught you and teach you. I will emphasize what you can do. So, for example, Dylan can use SPSS and at least up to intermediate advanced level of statistics. So that's a great skill. You can celebrate and you can emphasize in your job applications for state, local, and most of the business sector. Okay, because SPSS is one of the most widely and commonly used statistical software for the sectors. Okay. All right. Then other than that, you can actually do practice and just run some analysis, or if you, since it's between you and I, we are recording this one for Rahul, but otherwise you can just leave a class early and do your own thing and just practice your own thing, and you can ask me question later. So it's up to you, Dylan, what you want to do.
Well, I should. Yeah, I mean, I can leave early just to play around with SPSS. I also kind of want to do a little bit more research
Okay.
because I just don't. I was just looking, like, going back over my sources, and I just didn't. I was like, I think I need more, and I need to like amend some of my sources because I just don't. I don't know. There's a few of them that just are kind of relevant to what I'm asking, but they just don't seem as relevant to my research in general. So I kind of want to go back and like fix some of that.
Yes, and that's what I actually see from your literature review. And I see some of variables you can pull it out. You're gonna use the ANS data set, right?
Mhm.
I see some of the variables you can pull it out, but some of the variable as what we practiced before, you can make an index variable and how people really see the economic matters and just to convert that to some of the international relations, right? So exactly, and I see at least two or three, maybe 4 or 5 studies. Okay, you can actually pull out. There are the exact variables those studies looked into from ANS data set too. But you want to make sure this is not their study, but it's your study. So you can make that economic index variable and people's expectations for the international relations with the different dimensions in different depths and different, for example, index to make a stronger variable. So that's what you can make this statistics is strong, and especially it's impressive that when we had, although we have a alternative hypothesis, we have a very negative insight about economy, but it turned out actually overall Americans are not really. But when you say so, what about if we divide it into or look into different sector? That is exactly what statisticians we are doing. So you have a good statistician gene in your brain. Okay. All right. So you know what? I will actually you can leave, but I will be in class until for next 10 minutes or so. So if you somehow forget something, you want to come back, and I'll be still here. But I'll just feel free to leave, and I may stop the recording for Rahul. Right. So otherwise, may I will wait for other housekeeping issues for next class on Tuesday. So otherwise, stay well and healthy. And I really enjoyed just talking to you. And it's a really fun class.
Yeah. Awesome.
All
Thank you
right.
so much.
All right. Have a good afternoon, Dylan.
Yeah, you too.